So I'm about to discuss the warm-up using what I've heard already. Discussing the warm-up on the board to the left of the projector, or to the left of the projector screen. What do you notice of the following? A is negative x minus 2 over x plus 2. B is 1 minus 9x squared over 9x squared minus 1. And to address that warm-up problem, I heard the word opposites. I see a lot of opposites going on. Lots of opposites. If I look at the first one, well, wait a second. Everything is opposite. Think about the symbol we use in math to show an opposite. If I were to factor out a negative 1 out of the numerator in A, I'd get negative 1. Oh, I'm going to write it on my screen second hour for 6th and 7th hour. And then I'm also going to write it for you on the chalkboard. But if you took out a negative 1 in that numerator, you'd be left with x plus 2 over x plus 2, giving you the opposite symbol. And in the second one, if we took out a negative 1 in the numerator, we get 9x squared minus 1 over 9x squared minus 1. Reduce, and we get the opposite. We're going to need this information for what we're going to learn today. If you forgot to pick up a piece of paper, be sure you pick it up on the stool. Today's essential question is, how? How do we multiply and divide rational expressions? Do I remember how we did this freshman year? So first off, anytime we multiply rational expressions, we're always going to try to factor. We're going to factor anything with one or more terms. This means a positive or negativism. When I mean this, that it may mean a positive factor or a negative factor may be present, dealing with situations like the warm-up. Like, what if you see the exact opposites on top of each other? Can I factor out a negative? All right, we're going to determine if any factor of the numerator and denominator will reduce. And then you can actually reduce within a single fraction, or what I'm going to call cross-reduce. So within division of rationals, we cannot divide rational expressions, so we convert the problem into a division problem. I mean multiplication. We're going to change it into multiplication. Lo siento on that. In order to do this, we multiply by the reciprocal of the denominator. Algebra 1 teachers used it as KFC, keep, flip, change. I also like to refer to it as put your thing down, flip it, and reverse it. So if I'm looking at this monomial times monomial, or monomial over monomial times monomial over monomial, all of these are already in factored form. You're just trying to figure out, well, what cancels, or cross cancels, or reduces, or cross reduces. So I notice x squared divided by x squared becomes 1. I also notice, hey, there's y squared here. There's a y squared here. So how many y's total on the bottom is that? So yeah, it's y to the 4th on the bottom and y in the 4th on top. So technically, those two put together, let me put them in a different color. Y squared and y squared become y to the 4th, which also reduces with the y to the 4th in the numerator. And then we also look at the coefficients. Coefficients like 6 and 2 reduce. I could either reduce the 6 and the 2, or I could have reduced the 6 and the 18, or I could reduce the 10 and the 2, or I could reduce the 10 and the 18. So I'm just going to start here. 6 and 2 reduce to a 3, but then, wait a second, 3 and 18 also reduce to a 6. And then, wait a second, 6 and 10 also reduce. So substitute, you may want to rewind and let them watch it one more time. But we can pick out what to reduce and when, as long as they have the same factor. They have to have the same factor. So what are we left with? We're left with a y cubed up top here, a 5, and an x cubed. So let's put that in a decent order. That's 5x cubed y cubed all over a 2. Found an error. Supposed to be 3. I agree. Whenever 10 and 6 reduced, should have been 5/3. All right, moving on to the next one. What we're going to start doing is factoring. We're going to factor expressions when we see binomials, trinomials, and so on. We might use strategies like multiply, add, or bottoms up could possibly happen. Difference of squares, greatest common factor. And then we're going to see what factors look exactly the same. Or we're going to keep the warm-up in mind and figure out, wait a second, do I have an exact replica of what I'm looking at, just the opposite signs? Can I factor out a -1 or so on? All right, so numero dos. In the numerator, so far, I could factor the numerator to be, well, they both share a 2 and they both share an x. So we're looking at greatest common factor here. 2x times the quantity, whoop, 1 minus 9x squared. So what I'm going to do is, instead of this, I'm now going to represent it as 2x times 1 minus 3x, 1 plus 3x. Difference of squares there. Now, if one of these looks similar to something in the denominator, after I factor them all the pieces, then I'll take a negative out of one of the parentheses. But until then, no. Whoops, hold on. There it is. Okay, so let's go to the denominator of this guy. Denominator, 3x squared minus 2x minus 1. Instead of using bottoms up, I'm going to just try to make sense of the situation. In order for two things to multiply to 3x squared, how do you break it up? Had a question that said, hey, can we cancel out these 3x squareds before we start factoring? And it's a no, because in order to undo using division, you have to make sure everything's surrounded by multiplication. And these 3x squareds are not surrounded by multiplication. All right, so going back to this factoring, what times what could possibly get us 3x squared? So I hear x and a 3 and 1. So we have to have somewhere a 3, somewhere a 1. 3x times a 1x definitely gets us 3x squared. Or the only other combination would have the 1x first and the 3x last. Then you've got to ask yourself, how in the world do you multiply two things to get a 1? The only way you do that is having a 1 times a 1. And the last piece is to figure out, do we have minus signs or plus signs in the middle? So if you were to take your outer product, 3x, and your inner product, 1x, which one would get the negative symbol? So you could have done bottoms up with this, first off. Could have done bottoms up. It just takes a lot more work, and I'm lazy. Takes a lot of mental math skills to figure out, okay, this product combined with this product would get me that middle sum. You would have to have a negative 3x plus a 1x in order to get a negative 2. Ergo, the second one needs a minus sign. The first one needs a plus sign. If you would have done this using bottoms up, you would have been successful. The bad thing is typically we forget about that bottom, and then we forget about moving it up. Or, no, I shouldn't say that. Typically we're good about moving it up. We just forget about the bottom in the first place. Going to the next group. I'm going to use the same factoring idea of the only way I can get a 3x squared is by taking 3x times a 1x. The only way I can get a product of a 1 is by taking 1 and 1 times each other. And then I've got to figure out, how do I get a 3x product and a 1x product to get a negative 4x product? They both have to be negative. So negative 3x minus a 1x definitely gets us negative 4x. Again, you could have used bottoms up and be fine. Last, I got 4x. So we can cancel out monomials with monomials, binomials with binomials. What do we notice? What can cross cancel, or maybe what needs to be adjusted, like the warm up? So what we got so far, 1 plus 3x and 3x plus 1 do reduce because of the commutative property. 1 plus 3x is equivalent to 3x plus 1. And it's surrounded by multiplication. We also have x minus 1 in the denominator cross-canceling with x minus 1 in the numerator to the right. We also have these monomials. I'm going to circle the monomials. 2x and 4x also reduces. 2x and 4x reduces. 2x and 4x reduces to a 2. So let's see what we're left with. We're left with a 1 minus 3x up top times 3x minus 1 up top. Ooh, running out of room. Hold on. I need to shrink my work. So I've got a 1 minus 3x up top, 3x minus 1 up top, all over 2. I realize these two factors look uber similar, but they're opposites. So why not take out a negative 1? We could take out a negative 1, but it won't serve us a purpose. The reason why we would take out a negative 1 is to reduce a fraction, and that will not reduce a fraction. So let's go to number 3. Let's look at this big division, this big complex fraction. What we're going to do is keep change flip, or keep flip change. I guess the KFC from Algebra 1. Keep flip change. And then start factoring. So we're turning it into multiplication. Flip your second fraction. We're going to start factoring. I want to stress how you are allowed to use multiply, add, bottoms up, trying to figure this out. But multiplies to negative 6, adds to 5. I'm going to go with my crazy method of what multiplies to 2x squared, and the only way you can do it is with a 2x and an x. And the bad thing is, if you put, because it's not both ones, 3 and a 1 will go somewhere here. You've got to figure out, is it supposed to be 2 times 3 or 2 times 1? And the mix would be, I trust your bottoms up skills to eventually come up with 2x minus 1 and x plus 3. So if you're like, wait a second, I don't understand that method, go back to your bottoms up skills. The bottom one doesn't reduce. Top on the next one. Greatest common factor of 9. And then we have 1 minus 2x. A word of caution, we should notice something with the warm-up. So now that I'm saying, hey, look at this problem, we will have to take a negative 1 out of something because we do have opposites up there. It's your job to figure out which ones. Either we're going to take out a negative in this factor, 2x minus 1, or we're going to take out a negative in this factor. But you don't do both. You don't do both. So, because this one was said during second hour to take a negative out, that's the one I'm going to do. So instead of 2x minus 1, I'm going to erase it and put a negative out and put 1 minus 2x. I also want you to recognize how it's in color. You might want to highlight that. That was the special thing about warm-up. If we don't see the same factor or we see complete opposites, then we need to realize there's a negative factor. All right, now we can cross-cancel to reduce. Cross-reduce. So 1 minus 2x goes away. X plus 2 reduces. And we're left with, let's see, a negative, an x plus 3, and a 9. So if I want to write it appropriately, I'd have negative 9 as the coefficient times the quantity x plus 3. You could have also had negative 9x minus 27. That's fine. It's just not the purpose of the lesson. Let's go to the next one. Instead of looking at it as a division problem, I'm going to change it to multiplication. Keep flip change. This was not in a fraction, so technically it's over 1. So whenever we multiply by the reciprocal, it's 1 over that. Now let's start factoring. 6x squared minus 12x. It's not a trinomial, so we try to figure out a greatest common factor possibly. 6x and x minus 2. In the next binomial, there's no greatest common factor, so we try to use difference of two squares. X minus 2, x plus 2. And then we have a greatest common factor in the next denominator of a 4. Let's cross cancel. Or cross reduce, I should say. Ooh! Monomial 6x and monomial 4 can reduce. I should say the factor of 6 and the factor of 4 reduces. Notice how this 6 or this 6x monomial is surrounded by multiplication. This is when it's okay to affect a monomial, when it's surrounded by multiplication. So 6 and 4 reduce to a 3:2 ratio. Now let's see what we're left with. Three x over x minus 2 times x plus 2. And again, the x on top is a monomial, part of a monomial. The x's on bottom are parts of binomials. You can't undo them. So now we're going to go to the partner practice. I'm going to give you 4 problems. It's sort of like homework, but really not, because I want you to get it done now. So for 5 and 6, this is a 27. I want you to copy this down. Substitute, you may have to pause so they can write it down. And then I'm going to give you 2 division problems. So for the division problems, let's do those. So technically you have 4 problems for homework, but I want you to do it with your partner. Make sure you have the right answers before you leave. Or make sure you copied it down the same way. I'm going to have to travel back to this video to re-look at what did I assign, what was it, and so on.